Previously, we have discussed the pressure response downstream of a closing valve through which water is flowing. As a function of time, the pressure right after the valve drops and forms the following pattern. If, however, the pressure drops down to the vapor pressure, gas is formed, which is called cavitation, and the pressure response changes. Now, it is important to realize that elevated piping sections require special attention when evaluating potential cavitation. We again consider a piping section downstream of a valve. Now an elevated pipe section is included, for example a road crossing. During normal operation, the pressure profile, so the pressure versus location, shows a slowly decreasing pressure due to friction losses, with a dip at the location of the elevated section due to the hydrostatic pressure difference. Now, because the pressure is lower at this elevated section, there is an increased risk for cavitation, especially at the far end, even though the pressures are well above the vapor pressure during steady-state operation. Let's evaluate what can happen when the valve closes. At the valve location, the pressure drops and the associated pressure wave travels downstream, thereby reducing the pressure wherever it goes. No cavitation takes place at the location of the valve, since the pressure here is well above the vapor pressure. However, once the pressure wave reaches the elevated section, the vapor pressure is reached, and as a result, cavitation takes place. Again, gas is formed, which creates a vapor pocket at the elevated piping. This vapor pocket grows as more locations reach the vapor pressure. The vapor pocket causes column separation, as we now have two separate water columns in the system. Once the pressure stabilizes and a compression wave returns towards the valve, the vapor pocket reduces in size as vapor is now quickly converted back into liquid. This results in two water fronts that hit one another. This causes a new local pressure peak similar to a waterfront slamming into a closed valve. This pressure peak can be significant and in its turn causes pressure waves to run into the system. Because of the risk of column separation, it is important to pay special attention to elevated sections when evaluating the risk for cavitation in a system.